Welcome to Revit 1. In this course, you're going to learn how to work with Revit architecture to create building information models. In today's lesson, we're going to discuss some general BIM concepts and learn how Revit architecture can be used to create a wide range of intelligent building models. We'll look at the Revit interface and explore some of the key features of the software, such as parametric design concepts, constraints, and the interconnected relationships between views in a building information model. We'll also discuss how to begin your first project and learn some of the basic methods involved in creating building elements, adding features, and navigating a Revit building information model. BIM, or Building Information Modeling, is a new and revolutionary approach to the design and documentation of buildings. BIM allows you to manage the information related to a building through the entire life of the building design, from early conceptual designs through to detailed construction documentation, and even beyond the construction phase to facilities management throughout the life of the actual building. The information in building information modeling refers to all of the input that goes into the building design, including things like materials, wall construction, the number and type of doors and windows, floor areas and usage patterns, energy analysis, quantity takeoffs, and even cost estimates. All of this information is contained in an intelligent three-dimensional model of the building that can be viewed in a variety of ways and outputted to fully coordinated construction documents. There are many advantages to working with a BIM approach. Probably the most significant benefit is that developing a single building model as the basis for all related construction documents ensures coordination between different views of a model. When you delete a window in a plan view, this change will automatically be applied to the elevation views as well. The window schedule will also be updated at the same time. Any changes made to the model in any of its views will seamlessly and automatically be propagated to all other related views. I have a project open on the screen now that you're going to be doing in the second half of this course. It's a two-story residential house project, and I can show you just a bit of a preview about that coordination. Here we see that there are a couple of windows in the dining room on the front of the house. If I'd like to switch into the first floor plan view, by double-clicking here in the project browser, this takes us to what looks like a 2D view of the building, and we can zoom in, and these are the windows that we were just looking at in the 3D view. If I select this window and delete it, that window has been removed in the floor plan view, and if I check a south elevation, or if I go back to my 3D view, that window has been removed here as well. If I undo that operation, that window is going to be restored. I'll just redo to remove it. We'll go back to the first floor, and we can check an elevation view as well. And if I just switch to my elevation view by going into my project browser here on the left side of the screen and double-click to make that view active, here we can see that that window has also been removed in this view. If we have a window schedule that's been created, the window schedule is going to be automatically updated as well. And we'll just undo to bring that window back. Other benefits to working within a BIM approach include a better understanding of the building and its spaces by being able to easily view the model in 3D. Fewer errors in cross-referencing views and details, interference checking for conflicts among various structural, mechanical, and architectural elements, automated schedules and quantity takeoffs. If we'd like to see what this building is going to look like through this dormer section, I can go to a section view by double-clicking here on this section head annotation, and it will show me how this dormer is going to be constructed, and how the brick from the wall below is going to extend up in front of the frame, how the floor system is going to fit into that wall. So all of this is going to help us see how the building is going to fit together and if any conflicts are going to occur. Let's just go back to a 3D view. And I'm going to go through the interface here in a much more organized fashion. So we'll discuss all of these different sections, such as the properties palette and the project browser, in just a few moments. Revit architecture is the newest and most technologically advanced BIM application currently available. Revit software now encompasses the full spectrum of industries required to bring a building design to fruition. It has support for architectural, structural, MEP or mechanical, electrical, and plumbing disciplines. And all of those different options and disciplines are going to be available within a single program. We can have a set of architects working on the main building design. We can have structural consultants working with the same model and developing the reinforcing and the beams and columns and such. We can go to a systems section here, and we can have the mechanical engineers and the electrical consultants adding electrical information and ductwork and piping to our project as well. And everybody is going to be able to access the same central building model. Revit was designed from the ground up specifically to address the requirements of the BIM industry. The name Revit was derived by the original developers from the term revise instantly. And from the beginning, this platform was designed to be able to manage changes in the design of a building. Revit uses parametric objects and parametric relationships to help accommodate the inevitable changes that need to be executed when developing a model. A parametric object is an intelligent object that can have various sizes, materials, or other parameters assigned to it. These parameters can be accessed and modified through a dialog box, allowing you to quickly and easily create variations on a single object. A desk could have parameters such as length and width that could easily be modified without affecting the height of the object. If I zoom in on this window, we can adjust the size and the position of this window in a 3D view, in an elevation view, or in a plan view. We can move it around, or we can change its size. Currently, if I select this window, and I look over here on the left in the Properties palette, and this is where you can find all of the information about a selected object, it shows that this is a casement double window, 48 inches by 60 inches. And if I'd like to change this window to a different type or a different size, I can reach into this type pull down, and I can say that this is going to be not a 48 by 60 inch window, but a casement double with trim 32 by 60 inch window. And if I just pick this type and then pull my mouse out into the screen, that window is now changed. And now we see some trim elements on the outside, and it's reduced. I'll just undo to take that back. If I select the window and I look down in the Properties palette, it has a sill height value. And if I change this sill height value from 2 feet to 3 feet, and then apply that change, it's going to push that window up in the wall. And again, we can move this up or down just by selecting the window. And if I drop this down to 1.5, that's measured in feet, it will pull my window down. And you can see that the objects know how to relate to each other. So when the window pushes down into the stone section and the sill is cut away to make room for it. If I select this window and I delete it, the hole in the wall will automatically be healed and filled in. I'll just undo and undo again to reverse that sill height change, and we'll take this back to its original position. Parametric objects are a common feature in many modern software packages, but Revit extends the power of parametrics by allowing you to create intelligent relationships between objects. A floor, for example, can be attached to a set of walls which encompass the floor. When you move a wall to resize the structure, the floor will also automatically resize to follow the new shape of the surrounding walls. Many elements such as walls, floors, roofs, etc. are constrained to levels or critical heights defined in your building, such as the height of the floor above grade and the height of the ceiling above the floor. If you change the floor to ceiling height by moving one of those levels, all elements that are related to that level will automatically be adjusted. Let's just switch over to another project here. And this is a small commercial building that you're going to start developing today. And the levels here are shown as a second floor level. We have a top of plate 1 and a top of plate 2, and we have a roof level as well. If I select this wall, and I take a look here in the Properties palette, again selecting an object and then looking in the Properties area is going to give you information about that selected object. We see that this has a top constraint that says, if I just open this up to level 3 roof. So the height of this wall is actually linked to the position of this roof line. If I select this elevation and I increase the height of the roof from 20 feet to 24 feet, all of the walls in the building are going to move with it. If I take this down to 18 feet, it's going to lower the walls. So just by changing a single value here, we can adjust the entire shape and size of the building. In a regular CAD drawing, changing the position of an element, such as a window, by stretching it, will also update any associated dimensions. In Revit, this is also true, but it's taken a step further, as you can actually select any dimensioned element, such as a door or a wall, and its dimension values will be highlighted. Modifying that dimension value will actually modify the position or size of the dimensioned element. Dimensions are not only associative, as in regular AutoCAD or another CAD program, but are truly parametric, being able to drive the design. Let's take a look in the first floor plan view here, and I can illustrate this by coming in and selecting a window. We'll just pull in here to this area. Now we see that the window on the side of this office is located 9 feet 2 inches from the front of the building. If I select that window and I move it down in this direction, the dimension is going to automatically update. So now it's set to 5 feet 11 inches, but let's say that we want it at 8 feet. If I select this window, the dimensions are highlighted and they're editable. So if I select the 5 foot 11 value and I change this to 8 feet, not only does the dimension update, but the window is actually moved in that at the same time. So we can create these relationships between the dimensioned elements and the dimensions themselves. If I wanted to change the overall size of the building, we can do that as well. I'm just going to unpin this wall, and if I pick this back wall now and I say that the building needs to be 4 feet longer, and we change this to 46 feet, the building stays together. It increases the length. It increases the length of all of these rooms. That wall has moved back. The other walls that are connected to it have automatically extended. All of the elements that are inside those walls are going, such as the doors and windows, have moved along with it. And just by selecting this wall and changing this value on the side dimension, it's going to modify the size and the shape of the building. And again, any changes that I make in this view are automatically going to be applied in all other views as well. Annotation and sheet management is also fully parametric in Revit. Tags and detail notes are linked to objects and to the sheets on which views are placed. If you change a sheet number, all details on that sheet will automatically be renamed and renumbered in all other related views. Let's take a look at this. We can see that if I zoom in on this section head, this standard annotation is showing me that this particular section is going to be located as number 2, section or view number 2 on sheet A6. Now if I go into my project browser and I come down here to my sheet section, I can find sheet A6 and we can make that active by double clicking. And here are the 2 views that have been added to my sheet. We have one section, the longitudinal section at the top is view number 1, and our cross section is view number 2. The sheet number is A6. And if I change this sheet number by coming in here and I double click and change that from an A6 to an A16, first of all it's going to reorganize the numbering and move that sheet down to the bottom. But if I go back to my views now, and we can see even here right away that this view, this second view, number 1, that's being noted in this section, has now referenced sheet A16. This view as well, which is referencing the view below, the lower section, is on A16. If I go to my first floor plan, the section view notes have automatically updated, and this one as well. If I go to the second floor where those views are also going to be annotated, we have an A16 here as well. So all of our annotations and notes are also parametric and linked to each other and to the sheets, so that if we change one, they're going to change in the other locations as well. Revit can create logical relationships between elements, such as connected walls or windows within a wall. If you delete a wall, it's going to delete all of the hosted elements as well. If I come into this view and I select a door and delete it, those elements are going to be removed, but the wall remains. If I undo those operations and bring them back, but I delete the walls themselves, when I delete the walls, any hosted elements are also going to be deleted. And I'll just press Ctrl Z to bring that back. Additional user-defined rules may also be created to maintain dimensions or relationships between elements in your model. For example, you might wish to define a window as being placed in the middle of a gable wall. If the wall changes width, the window will automatically be moved to maintain the equal distance of wall on either side. This can be accomplished with something called an equal dimension constraint. Let's just go back to our first floor sheet. And if I would like this window, let's see, it's already in the middle. Let's just move this out. I'm going to activate this view, and I'm going to pull this down to 3. We'll select this dimension. I'll choose Edit Witness Line, and I'll add another location and pick a point. Now, this dimension has an EQ value, or an equality constraint value. And if I change this and just say that I want this to be equal, then it's going to move that window into a new position. If I change the position of the wall, and I select this wall, and you can see that this is showing some constraints to another wall here, and I pull this down, it's going to pull the other walls along with it. If I select this dimension here and I unlock this value and I move this wall down, this time we've actually increased the inset distance here from 8 feet to 10 foot 6. And when we did that, it automatically maintained this equal value so that the window remains centered in the wall. If we select this wall and I change this value to 9, one wall moves in, another wall moves in, because we've said that we want to create an alignment constraint between the two front walls. So when you move one wall, other things can happen at the same time. Another wall can be linked to the first, so it moves at the same time, and relationships such as a window being located in the middle of a wall can be maintained. If we want this window to always be aligned so that it's in line with the opposite window on the other side here, we can create an alignment constraint. And I can say that I want this to be my base alignment, and I want this window to shift down so that they're going to be locked together. And I can lock that as well. If we move one window now, let's say I turn that equality value off, and I select this window, and I change this 4 foot 6 value to 3 feet. When that window pulls down to 3 feet, this window pulls down at the same time. If I select this window and I say that it's going to be equal again, or if I pick the dimension here and I apply my equality constraint and it shifts up, it's going to move the window on the other side as well. Objects can be locked with alignment constraints. You can lock dimension values so that they can't be modified. Now if I move this front wall, it's going to move the inside wall as well. If that dimension is unlocked, and I move this, changing this to 8 feet, we can pull that wall up. If I want this wall to be able to move independently from the wall on the other side, we can remove that constraint. And I can unlock this alignment. And now when I select one wall and I increase this distance to 10 feet, it will move down, but the other wall will stay where it is. To create that relationship again, I can create an alignment, and I can say that I want this to be my controlling feature, and I want the second feature to move down to it and lock with it. And then if I change this value to 8 feet, it's going to move the other wall with it. So we can create all of these intelligent relationships between the elements. Now it's really kind of fun to add all of these constraints and these alignments and locks. You do need to be careful and not put too many in. Just because you can doesn't mean that you necessarily should lock everything down or create too many constraints and alignments. When you add too many constraints and alignments, the model size will get too large, and sometimes you'll get unintended consequences. If the relationships and the locks and constraints can propagate and compound across the project, so that you can change the location of a wall on one side of the building and a window on the far side of the wall of the building might move as well. All right, we're going to take a quick break, and when we come back, we're going to go through the parts of the Revit interface in more detail and discuss how you can access different commands and start a project. And we'll just take a quick break and come back in a few minutes to get into that portion.